everyone. Welcome you all back to the subject of Industrial Engineering and Management. This video will be seeing about the remaining part of Unit 4. The topics which are marked in red are the ones which we'll be discussing in this video. We'll see about the quality tools, especially the most sought tools, the 7 traditional tools, which is also called as the 7 QC tools. What is QC tools or what is quality control tools? What is the need to learn these tools? It is because everywhere, every industry is focusing towards achieving customer satisfaction. So how do you achieve customer satisfaction? It is through delivering the product which meets the customer requirement. So how do you ensure that the product meets the customer requirement? It is by analyzing or by identifying any possible means of deviation in the product characteristics which will dissatisfy the customer. So how do you measure this characteristics which is not conforming to the requirement? That is what you call as the gap. So a problem is an undesirable event, or you also call them to be a gap between what is expected and what is obtained. And all the efforts which have been put in to reduce this gap is called as problem solving. So problem solving, QC tools have been the most sorted tools for all the problem solving methodologies in an organization, because they have this advantage of collecting so much of data, and it helps you to analyze the data and identify the root causes through which you can measure the desired results. What are the 7 QC tools? Why it is called as traditional tool? It is because these are the most conventional tools which have been in practice for a very long time, and most of the Japanese industries, they from their experience, they see that 7 QC tools have been the ideal for any problems which have been arising in the industries. And to quote a famous saying by Professor Kaoru Ishikawa, who is also developed this PDCA cycle or the PDSA cycle, he has been saying that it has, through the experience, 95% of the problems at the workplace can be solved with these 7 tools. So he is one of the most pioneer of, it's also called as the quality guru. What are those 7 quality tools are? First one is the process flowchart. In no particular order, it has been denoted here. Process flowchart is also called a stratification diagram. Second one is check sheet. Third one is histogram, Pareto analysis, cause and effect diagram, scatter diagram, and the last one is control charts. Now let's discuss about each of the tools individually. First one is check sheet. What is check sheet? Long ago, we have been using these check sheets even without knowing that this has been one of the quality tools. A good example can be probably people who have been to temples in the rural areas. You could see that there would have been a black color lines which have been marked, counting that how many rounds they have made surrounding the temple. It is that kind of methodology which we have been practicing, incorporating in our daily life. So it is as simple as that. It is very easiest way of collecting the data and analyzing them. So how do you define check sheet? It is a sheet which is designed in advance to allow easy collection and aggregation of data. Just by entering the check marks on a check sheet, the data can be collected, and through proper inspection, you can eliminate all possible ways of any errors which have been creeping in. And it also helps you in an effective way by performing stratification, which is called as categorization. It helps you to categorize the data into a set of volumes. Probably that will help the analysis to have a greater picture about what has been the process, how has been the process moving on. A sample check sheet is shown on the right. We'll see about this is again an example of a small check sheet which has been used. Probably you can also relate to how people have been using these check sheets. Even for counting, we usually go this criteria, right? We put 1, 2, 3, 4 lines, which indicates the count is 4, and if it is cut by a cross line, then you count that to be a 5. So you could see here the counting is quite easy here. 5, 5, 5, 5, which means 15. Sorry, 20, and this is 4. This is 4, 28, 230. 232, 133, 134, and 236. So the total count is 36. What is the desired results of the check sheet is that it ensures collection of the required data, and through proper inspection of all the items, you can understand how the process is having, if the process is having any variations, or is there any slight tendency of the process to move away from the required standard performance? So an example of check sheet is listed here. So for a week time, how many defective types and how many events have occurred? Depending, you have categorized them into different, like the wrong part being issued, incorrect dimension, adhesive failure being the type of defect, and you count that on a weekly basis, and you'll be able to find out what is the total number of defects that have been occurred over a period of time. The second tool is your Pareto chart. Pareto chart is basically a combination of a bar and line graph. Bar chart, we all knew, we have been using it quite common. So bar charts represent the actual data in descending order, whereas a line graph represents the cumulative data in the ascending order. So a Pareto diagram utilizes this concept, and it is also called as 80-20 chart or 80-20 rule. What does this 80-20 rule? States that 80% of the problems or the outcomes are based on 20% of the causes. So it helps in a way that you can prioritize the action by arranging the elements in descending order of occurrence, which means that the issues which have been creeping in most often have to be given the highest priority, and the one which have been occurring in a very minimal time, the priority can be given at the last. So that kind of analysis, it helps you to find. So a good example can be a defect is found or any failures, a complaint from the customers. You just divide them into smaller groups based upon the phenomenon, and then you just sort it out, and then the total number of occurrences are then calculated. You can see here what does the Pareto diagram, or how does the result of Pareto diagram looks like. It helps you to clarify what are the important tasks, and moreover, the starting point of the entire analysis can be identified using this chart, and also it helps you to allows in the projection of effects of a measure to be taken. So how much of efforts to be taken, and what could be the desired results for it. And again, an example has been listed here. It has the total sales on the y-axis, and the different kind of products in a supermarket, or probably in a shop. You can get the beverages. You could see that, as you said, the bar graph always shows the values in the descending order, whereas in line graph always shows the ascending order, right? So you could see that the cumulative sales data have been listed here, and the individual states data have been listed in the descending order. So you could now see that what is the actual trend here. You could see here this is the ideal line, or probably the way in which you could analyze beverages, dairy products. These two predominantly contribute to the maximum number of sales, right? So when higher the number of sales, higher the number of beverages sales, and you could see that the total number of sales which have been higher for beverages. So that kind of most importantly, very recently also we could see that ICMR have been utilizing this Pareto chart for using the COVID times, right? I hope if not, many people could remember that. We have been saying about the number of cases in the ICMR website, where they have been listing about the number of cases in the previous day, the today's day, and which state is having the highest number of cases, and what could be which are the states which are driving the second wave and third waves of COVID in India, right? So many such examples you can quote. That's why the 80-20 rule, irrespective of the industry here, you could apply this 80-20 rule to any platform, and obviously the results will indicate the same, that 80% of the problems are due to 20% of the causes. The third category is your cause and effect diagram. What this cause and effect diagram gives you is that it gives a kind of relationship diagram which shows what are the various causes which coherently adhere and which have been leading to a particular effect. So it is also called as a fishbone diagram, as maybe when you look up to the slide next one, you could see that the structure looks like kind of fishbone diagram, and it helps you to analyze the problem in a more scientific manner by identifying what is the root cause, what are the causes of it, and what is the effect, and how far this cause is influencing that effect. That could be easily understood when you use this cause and effect diagram. You could see here, usually it is categorized as men, machine, material, and method. That is how these are the causes. Now, you could take the example which has been listed here. My cup of tea was cold. That is my problem, or probably my effect. So what could be the causes for it? And the material, when it comes to material, you could see that the cold water can be one of the root causes. When it comes to man, you could see that the this ignorance of turning the kettle on, or probably not plugging the kettle, or not checking the temperature could be the root causes. And then the major cause of machine, you could see that the element got broken down, or probably the kettle is not working. And when it comes to method, there was no standard operating procedures which has been clearly mentioned. So it helps you in a way that this, when for a particular effect, what could be the causes, and for those causes, what could be the root causes, and you could then find the relationship between them. That this way you could see that even a clear cut or probably a microscopic analysis can be done, which helps in identifying what are the root causes, which in turn which is affecting a particular problem, or which in turn is causing a particular effect on the production process, right? And as I said, the skeleton looks like a kind of a fishbone, right? So it is also called as a fishbone diagram. The fourth one is your stratification, which is also called as a process flow chart. There is a name, of course. The first line we have mentioned it has to be a process flow chart, but it is also called as a flow chart or a run chart. It helps in a way to organize the data, and more particularly kind of categorize the data into a particular sort of groups, right? So what in general stratification refers to is dividing the whole into smaller portions according to certain criteria, and that criteria is depending upon their requirement, what kind of analysis they are going to be doing, and what is output they are going to be expecting. So that kind of idea will give you a picture about the fixing of the criteria, and the criteria, depending upon that, the whole process is divided into smaller portions. So what you could see that this process of fostering and understanding of a situation and dividing into groups, it is one of the most important aspect of your quality control, right? So quality control, it's about validation. Verification is about quality assurance is about verification, and quality control is about validation. So each of the points in the dataset has to be included in only one group. You cannot duplicate that, or you cannot have a copy of it. You cannot keep that for the next dataset. So that means that no points will be left out at the end of the observation. A good example is listed here. Different categorization. Group 1, probably red color denotes you could take about any particular parameter, the blood pressure of a patient. Probably group 2 refers to the heartbeat and oxygen level up, and group 3 refers to his pulse, right? So you can categorize them into different categories, and these are the observations you could see here. And one of the key important aspect of stratification, or probably the process chart or flow chart, is that it helps you to group by any classification, maybe probably grouping by day, by time, place, or process. Yeah, again, an example of how name of the units in terms of X, you denote it by a particular symbol, and there are a few standard symbols too. The similar symbols which we will use for a flow chart, right? The decision making, if it is probably a decision making process, then you go for your diamond shaped, and if it is an operation or a process which has been happening, you go for a circle or probably square, something like that, right? So what could be the result of stratification diagram? That it helps you in observation of variation among the different data points which you have calculated, and it helps by performing a cost analysis using this data, through which you can identify and control a problem. And also the division of data into several groups helps in easier identification of the variations. If in case you see that any of these yellow parts are closer to the red dots, or probably any green dots are closer to the yellow ones, you could see that there is a tendency of variation which have been prevailing, and you can then find out what could be the root causes for it, and more of an attention can be given to the particular observations or the process. The first one is your control chart. So what control chart gives you is that it again one of the very useful tool. Of course, it's a very big topic of, you can conduct it for probably 3 hours or 4 hours of time, but in general, control chart is used to examine the process, if it is stable or maintain the stability of the process. It gives you clear-cut information, a clear-cut idea about how the process or observations are about, and what are their deviations and the tendencies are moving towards, right? So you have two different categories of control chart. One is the control chart for variables, the other one is control chart for attributes. So in control chart for variables, you have X bar, R, and S chart, whereas control chart for attributes, you have P, N, P, C, and U. Depending upon the type of application, the type of data which you are utilizing, the type of chart has to be decided, right? An example of control chart you could see here. This is a process habit. It predominantly uses the concept of mean, median, and standard deviation, which is the basic concept of your statistics. So when you find that there is a process average, you fix up an upper control limit, which is the maximum limit, and lower control limit is the bottommost level. Beyond both, you will not be able to accept the particular observation of the particular process. You could see here, predominant of the observations are falling within the control range except this particular point, which means that this point or this observation is outside the control limit, hence it is out of control point, and that is a deviation. Whereas you could see there this process, even though this is your ideal condition, right, you could see this observation number 2, observation 1 and 2 are very closer to the process average. The observation 4 might be differing, so might be due to a common cause or a normal variation. Again, the process variation here, you could see here observation number 12 and the 13, even though there are quite huge differences in terms of the numbers, because they are almost closer to the averages, right? So it helps you to categorize the data and identify any change which is caused by elapse of time. Also, if the process is in normal stage or there are any anomalies which have been present, you can identify that using this control chart. That is one of the key important observations of control chart, which helps in to look up or to analyze the data for a function of time. As the time goes by, how far the process is behaving or how far the observations are moving, that kind of analysis can be done using this control chart. The next one is your scatter diagram. A scatter diagram is used to examine the relationship between a pair interrelated data types, probably something which are very similar to, probably which are easier to correlate, like height and weight of a person can be easily correlated, right? So that is how a scatter diagram, and it is used to determine how they are closely related to each other and identify a problem point that could be controlled or improved individually. So the dependent axis is usually kept in the y-axis and the independent one is kept on the x-axis. An example is shown here. You could see here degrees of how you can relate to that correlation is that there is no sort of correlation you could see, and you could see there is very lesser correlation, whereas there is very high correlation here. All the observations are falling very closer to the ideal value, and this is the perfect correlation where you could see that every process is lying on the actual expected line, right? And this is a positive correlation where which indicates that, and every increase in the x-axis, which is your independent variable, there is the dependent variable will keeps on increasing. Whereas this is a negative correlation where every increase in your independent variable, there is a decrease in your dependent variable, right? So this is this kind of observation will give you that there is a negative correlation among the two parameters which you have been choosing. And this is a partial correlation. This is a kind of a curve correlation. Depends upon how the analysis type of data which you are using it for your analysis, right? The last one is your histogram. So what histogram gives you is that the variation in the process can be easily seen here. It usually gives in terms of vertical rectangular bars. And when one of the key important thing to be noted on is that when creating a histogram, the range of data is divided into smaller sections, probably having uniform span rather than having a varied span. And the number of data contained in each section is counted to ensure that a frequency distribution table is created, right? So I put up an example here. You could see here the arrivals per minute in an airport and the frequency have been listed here. So for arrivals in an airport, you could see here you can cluster it from per minute from minute 2 to 5, where predominantly most of the arrivals have been happening. So that helps you to analyze what is the location of the central value. You could see here from minute 2 to 6, that is where most of the passengers have been arriving. So you could this is where you could fix your central deviation or probably the central value. So this histogram helps you to create or locate that mean value, and it helps you to identify the kind of distribution, whether it is an isolated distribution or an extreme value. Now this is closely related to your normal distribution, right? Probably I can draw that and show you. You could see here somehow closely relates to your normal distribution, right? Whereas if in case it is distributed in this way, then you don't see that to be a normal distribution. So it gives you to analyze what kind of distribution it is there, and the problem where there need to be proper attention has to be given. All that needs to be that can be easily analyzed using this histogram, right? You could see there that it is an ideal normal distribution curve, right? And the range of variations, and this is the standard range in which it has been fixed. There's an additional tool called graphs. Obviously, everyone knew what graphs are about, and it is a graphical representation of data. Why we discuss about that in addition is that it is actually a part of a quality tool which can be used for all the 7 tools in common, right? So graphs are effectively means to monitor the judge's situation, which helps in quicker and precise understanding of the actual condition. You could see here the bar, maybe I'm not probably I'm not going that much in detail because everyone knew how a graph is to be drawn. So for a sequential order line, for every change in time, there is a sequential order line graph. So the bar graph and other details have been listed. Pie graph, band chart, different types of bar graphs and pie charts are used here, right? So uh, I hope you'll be much more clearer with the graphs. It's one of the very common tool which is used for common technique which is used for all the 7 quality tools in common. To put it on a whole, in a nutshell, the summary is the stratification of flowchart is used where basic processing is performed when collecting the data, and Pareto chart it is used to identify the current status and issues, whereas to find out the cause and effect of those relationships, we use the cause and effect diagram, and to know how the data have been distributed, whether it has been uniformly distributed or randomly distributed, we go for histogram, and to identify the relationship between two particular set of data, we go for a scatter die, and check sheet is a very basic tool where it's only about collecting a collection of data. And to find out any anomalies or identify the status of current process, we go for the control charts where the graphs are commonly used, right? So the control chart is actually of those 7 chart, control chart is one of the key important thing to be studied because that helps you in clear indication about the anomalies or the discrepancies which have been occurring in the process. And through that, you'll be able to identify what is the deviation and which is the particular observation or particular point where proper attention or additional attention maintenance have to be given to ensure that the process is staying online, it is smooth and it is not moving out of the control limits, right? Few of the applications of QC tools in problem solving, identification of the, and again an example of correlation here. When there is a strong relationship between these two parameters, it is denoted by the symbols of double circles, and then if it is a single circle, it indicates that there is a very normal correlation. You can also relate like detecting of causes and problem. Graphs, check sheets do not have any direct relationship. Of course, stratification helps you to detect the cause and problem, but whereas, as I said, cause and effect diagram is one of the key important tool of these of the entire 7 tools. Cause and effect diagram is one of the key important tool which helps in easier identification of the problem. Of course, histogram will provide you the actual variations and how far the mean value or center value is behaving. And scatter diagram gives the helps you to analyze the data, how the values are closely related to each other, right? So you could see the various application of QC tools here, depending upon the type of problem solving. For evaluation of result, cause and effect diagram, histogram, and scatter diagram seems to be the more correlated one, whereas graphs and stratification have been seen to be the lesser correlation. But for identification of problem, you could see cause and effect diagram and histogram or scatter diagram do not possess any significant relationship. But on the other hand, Pareto diagram and graphs will help you will be the most ideal tool for identifying the problem, especially when you are at the initial stage of implementing the quality techniques in the industry. I hope with this video you'll be much clearer about the various quality tools, the 7 quality tools which have been used most common in the industries. As said by Ishikawa, 95% of the problems could be addressed using these tools. That has been the experience from Japanese people. And this video would have given you an overview about how to use the 7 quality tools when for a particular problem in an industry. Thank you for your patience listening. With that, we'll be completing this unit 4. We will see about unit 5 in the next videos. Thank you.